So this is Physics 103. This is on nuclear physics. And here we are going to solve another example for carbon dating. So in September 1991, some German tourists were exploring the Alps, particularly the Italian Alps, and they found a Stone Age traveler preserved in a block of ice. So they called it the Iceman. So the Iceman lived a long time ago, and they want to determine particularly at how much time how much time had passed before September of 1991 and the time that it stopped taking in carbon atoms. So they used radioactive dating, and they found that the activity of carbon-14 atoms inside the body of this Iceman in September 1991 is this one. So 0.21 becquerels per 1 gram of carbon-12. So in 1 gram of carbon-12, you have carbon-14 atoms, and those carbon-14 atoms has an activity of 0.21 becquerels in 1 gram. So previously, we have determined that the initial activity of 1 gram of carbon-12 is 0.23 becquerels. So per gram. So this is the initial activity. So we have an equation wherein A of t equals the initial activity times e to the minus lambda of t. So if we solve for t, we have here the current activity and the initial activity in 1 gram of carbon-12. So let's solve for t. So A of t over A naught equals e to the minus lambda of t, and taking natural log of both sides. So ln of we have here minus lambda of t equals ln of A of t over A naught. Then solving for t, we have minus ln of A of t over A naught. So we know that the activity the current activity when they found it on September 1991. So that is, there should be minus lambda t. So that is like negative 1 over lambda ln of, so the initial activity is A